All right. Well, that really sucked. Um, yeah, I just like totally lost the stream, and I didn't. I only would have caught it. I only caught it because I just saw out of the corner of my eye the smallest possible little error message that tell me. Anyway, mid rant, still middle of the rant. Um, we are trying to turn our OS platform layer abstraction here from a real loser to something that has definitely made me go slower and had to fight to figure out how the code should be structured in a lot of places earlier than I wanted to, into something that is going to really help us here, because this is like the actual this is now going to become actual business logic, because it's how we support multiple platforms that the game can actually work on. And you know what they say, first first win 32, then foundation, then the world. I don't know anyone who says that, but as we go around, I'm sure we'll find who has the most fun platform SDK to develop for. Right now it's definitely Mac because oh boy, we get to learn all this Objective C stuff on the fly, which is fantastic. One that I have no idea. I have like no exposure really to it all, is WASM, but I think this one is also pretty worth developing out. Unfortunately for me, because this is like how if we were to do a release the game to itch, which is something very much want to do, should be able to play it in browser and just have it work, and then we get a lot more people touching the game, a lot less having to screw around with making sure like the all of like the resources are bundled in the right place correctly before we go release something publicly, which we may or may not want to do, right? So that's that on that. And we shouldn't like screw around too much here, to before we but we should not screw around looking at this too much before we go back to our actual thing, but oh well. It does look like you just like throw a special compiler at it, and then you have, I don't know, it has to be more complicated than that. Like, so this is like the loop maybe, and then you have to actually have the HTML shell around it too, which we may not if we're going through itch.io to host it. But also somehow I think this is going to, we need to be using some kind of render API as part of this, and I think unfortunately that does mean learning some OpenGL as well down the road, because I think that is what most WASM things that I've heard of, they seem to be targeting, because it has to be pretty globally supported, right? It has to work kind of everywhere. It has to work in the browser sandbox, all this stuff. And OpenGL is not like a total I think if we're comparing it to like a Vulkan or whatever else for writing a native thing, I think it is still the case that we don't want to care about it. But if we ever want like an Android version of something, and this is like a million years down the road, an Android version of something, or maybe even a native Linux, whatever that means, port of the thing, like OpenGL seems like more important there to me, which is annoying. But I don't know. There's only so much time in the day to yap out about all this stuff. We have to get back to work here. So we have that's all to say. That was all to say, essentially, that this is kind of appears to be a bunch of shit work, basically, of just kind of refactoring the code to make it more split up in a bunch of seemingly arbitrary spots right now. But this is actually the most critical part, I think, of doing the of doing this multi-platform support here, of making sure this is the part where we actually check which abstractions make sense and can work with that or against that. And then, when that is working well enough, then we can do the fun part and actually write to the Metal 3 rendering pipeline. Because actually, that does sound fun and interesting to do that. But we've got a long way to go, I think, before we need to fix all the compile errors first, of course. So, long-winded way of saying that we burned most of the stream time up, but we've got to get grooving here somehow. So I gotta find I would like to find. Oh, this is not great. This is I don't know if this is not compiling because that's a problem. Because we are telling Clang to use Objective-C++, and this is a bunch of syntax crap or macro math or magic on top of macro magic right here. We probably do not want to be dumping that all preprocessor anymore, honestly, especially if it just does not work. So something to change. So that's on the list. This stupid fmin thing, that is so irritating, because I know that this min thing is just like a generic macro on Windows, right? That just worked, and we didn't need to turn it into the fmin thing, right? So that's kind of irritating. That's kind of irritating because here are the things where it's a battle, right? Of we want the code to continue being as easy for us to work with everywhere as possible, but like the more places that it has to be supported, the more platforms we have to support with any individual piece of it, the more constraints that we push onto it. That maybe become more and more burdensome, right? If I like cannot do any preprocessor stuff that is useful, like I think even Pragma once is not really supported by Objective-C from what I learned, but it just happens to work in the Apple fork of Clang. So that's not great. That's not great that like most, because this is like if we don't have this, then we start like going down some really annoying paths of having to rewrite everything to fit some other build model or pull in like a CMake to really generate a bunch of shit to manage that. I just don't want to do that. I would so prefer to limit the amount of tooling needed to work on this game to literally just having the platform SDK installed, and that's it. That would be incredible, because then we don't have to shit around like building up a dependency list or doing this and that garbage. So where to start here? I think actually it is still in the graphics layer here. This is probably the part of the code base that is the most important, because this is where like some real ownership is transferring between the game engine managed data to platform managed data. So like the the V buffer, loading the sprite sheet and the font atlas into memory. All this stuff kind of all lives right here. And so, I think like something like this function call, like graphics init image, this is basically purely a D3D thing. So maybe it should just live in the D3D layer, right? That's one option. I guess unfortunately, I think there's basically not enough time here to like really do too much. Spent too long yapping, and also I was up like super late last night, working on a bunch of this stuff. So, whoops. Took away from the stream being more interesting, unfortunately. What is up, TL Security? How are you doing, bro? We are doing some fun stuff here, working on the Mac port of my game engine. And this is the part where I have to draw a whole bunch of lines about how much stuff is abstracted and how much stuff is going to be available per platform. But this is like a whole problem. This dealing with splitting up all this like stuff that's just hard coded to D3D and Win32 and segregating that off into its own space. But I think actually it's not the most important thing to worry about. I think this problem here of I think this problem of the preprocessor stuff not really working with Objective-C++. Oh, good, man. It's this this stream has not been the most consistent over the date or over the years now, I guess. I've moved into like a new place about 2 months ago, and since then it has been pretty tight. We've been able to stream most every weekday, but not always. This is definitely the most concerning thing to me, I think, right now. All of like massaging a bunch of C code into the right spot is very doable. But if the compiler, if setting this compiler flag to have Objective-C++ work breaks the preprocessor, that is going to just throw error like syntax errors like all over the freaking place. And so I want to see. Let's go to Mr. Jippity here, with the objective flag on Clang. I get a bunch of preprocessor looking errors. Compiling formerly just C++ 11 code. Yeah, let's throw it at that one. Let's see what we can scrounge up. I also might be blowing smoke up your butt because this could just be specifically they implemented this wrong, or they implemented this min differently. But this thing right here not working disturbs me. This macro breaking 2 layers deep. I could not tell you why. I did also have to change this. I had printf-s, which I think should just be in the C standard lib. Like if you look, like, okay, the top thing is from Microsoft, but this is in the C runtime, in at least the VS 2022 version. So it should be in C++, whatever standard supports in there. And if you look like on CPP reference, they have a printfs since C11, right? So maybe the thing to do, because I think this is like really a problem. How's it going, Antonio Morales? How are you doing? Oh, sorry about that, TL Security. My stream time I think is a little unfortunate for most people because it happens. I have like about 45 minutes to an hour in the mornings before I have to go off to work, and that's about the only time I have to stream. Uh, so how about we try that? How about we chuck in the C11 standard in here too, and we will actually bring that over to Clang as well. Clanged. It did not like. Oh crap. Yeah, that is a problem, isn't it? That is most certainly a problem. Objective. Let's see. Because it's basically, I think, treating every single source file as Objective C++. Oh god. Oh no, it defines like class. And we're not using class, which is okay. We definitely could be using a bunch of assert macros though. Oh god. Yeah, that is really spooky. I do kind of need the interop though somewhere. But the problem, I mean, if I like just, I don't really have a great spot to split it up where like I could be compiling one as one part of the code base is Objective C and the other part is C++. Oh, that sucks. Oh, that really sucks. Because basically, mm, mm. Anywhere that I need Objective C syntax has to be a file, unless I get rid of this global set it to Objective C++. Yeah, so we do that again. Yeah, no, it's mostly for my own entertainment. That's kind of like what keeps me going, and I think it's useful to just kind of rubber duck stuff a lot of the time. It is something that has been handy. Learning a bunch of broadcast stuff has actually been very useful for work, and just practicing speaking in general has been good. So it's really this is something where I kind of see it going absolutely nowhere because I just am not. It's not my main focus. The main focus is doing this independent game development here. But it's just nice to have like some other thing that I can mostly passively just have going on at the same time. Yeah. But maybe one day, if I ever get laid off, you can expect the streams to start appearing at much more reasonable times. So that would be a problem. Yeah. So let me think here. There's like a number of things we could do. Like we could dump basically every single thing that talks to Objective C directly into Mac main, right? Mac main and like metal.mm, places like that. If we do that, it will fix some of our like weird compiling problem stuff. but then the Mac main and metal object files must have a interface that the rest of the code interacts with. That's basically just pure C++. Or even more ideally, probably just pure C would be the most widely compatible here. It's a little tough because definitely things were not built out that way with the D3D stuff. And the annoying thing is having to funnel everything right now through this common type header. Because I think basically, right now I'm trying to keep as much of the way this is modeled to work with the Win32 stuff as possible. And I think that's just not going to happen. I think that having to do this Objective-C interop has proved that this is just not workable in this way, and that likely we are going to have to centralize all of the platform-specific stuff in order to really get things grooving here. So, that's my alarm. But fear not, we will keep going for like another 5 minutes here. I want to look at, let's look at Ted Bendixson's code again. His his awesome example for how to do this very thing, this splitting up a game into all sorts of different platform layers to be able to develop for all of them. I know he did a WASM version of this at some point. I don't know if he ever published the source code for that live, but that would be cool to look at some point. I think he did things kind of like the reverse way of how I'm doing it right now. So he has his OSX main, I think, has his entry point, right? But I don't know how we go from this entry point into, it does a bunch of the init stuff, platform specific memory management, or memory API, render API calls, sound buffer junk, windowing junk. How does this just get into the game loop, right? How does that work? There's some sort of game app delegate thing here. I think this, I don't understand that NS application main stuff yet, how that entry point sort of works. That's something to uncover here. And again, unfortunately, not doing much coding, because this is kind of something I want to understand a little bit better before flailing around just refactoring stuff left and right. Not that we haven't been doing a bunch of flailing around, but if we look, one thing to consider too is, these things don't have to be the game and the platform layer stuff don't necessarily have to be compiled and assembled into one thing, into one object. And if you go back to the old ways, if you go back to Handmade Hero itself, if we go to the index, our favorite list here, one of the things that Casey did back in the day was splitting that up so that you can just be compiling a game library that has most of your code that matters, and the platform library separate and that's the executable that just launches that dynamically loads the game library. And that also lets you do stuff like this, where you can have the game open, just recompile the game library, and then you're hot reloading from the platform wrapper, right? Uh, and that actually is maybe something super useful. I never spent the time to try to get that to work on Windows, but that is like it is a generally useful feature, um, and it may be the right time to do it when we are looking at splitting these things up already right now into basically separate compile units, compiling to different like language and or languages and standards, right? That is a super possible as a path here. Um, if we look at like the Ted's invocate or all his compiler invocations here, tried C++. Yeah, no, this is not even a C++ problem. This is like if you were just doing C++ single platform, like you'd be done already, and we were done already, like on Windows. It's really just this like interop crap, and the fact that like Steve Jobs 25 years ago had to go put all his money into Objective C to build like Darwin, all the stuff on top of Darwin to make Mac OS, and now developing for native Mac apps is stuck in this like awful place where you have to interop with this proprietary freaking language that no one else on the planet cares about or wants to support, right? And that is the real problem. The real problem is Objective C++. Objective C. Yeah. That's the problem. But anyway, like no, I think Ted is just compiling everything to one thing. It looks like. Oh wait, no, game platform layer. Fast. Mm, mm, mm. Mm, mm, mm. But I think he does. If I grep around, I say as I just like look around. This is like his like game code. This is like his split up version of that. And he has like a game main that is the entry point, and he did the thing. He extern C'd it, so it has like a common C interface to all this stuff. Which is one thing I do want to would be good to understand is if that is reasonable, or if that interops better with Objective C than C++ does. That would be very good to know, because we are reliant on a bunch of like random C++ syntax and like semantic sugar, basically all like the a bunch of like magic preprocessor stuff. But I'm not using templates anywhere really. I'm not really using classes anywhere too. But I am working with a bunch of Win32 stuff that I think is written to a C interface. But I could be wrong. I could be wrong. Okay, let's see here. I think unfortunately we have to go open a new buffer to really be able to look around in here to try to find. Basically we are looking in this C++ code. He's got a function here called game update. Game update is one of in video game development, if you don't know, it is basically like your game is a program that's running in an infinite loop, and it does three things every time it goes through the loop. It pulls in I/O from the operating system. It goes and updates the internal state of the game, so like where the game logic thinks everything is, and then it does the rendering and puts everything on the screen. And that is like the most common basically design pattern for how you do like immediate mode rendering, basically, but also do video game stuff. Yes, yeah, Python was my very first game writing thing after I graduated from Scratch Academy. That was fun. But yeah, so it's a game update, game render. We want to figure out like where this is called basically. Why did whatever. If we look here, so it's getting called one time here in shared Apple platform, because I think there's a lot of overlap between Mac OS and iOS for developing to it. And then once here in Windows. So let's look at the Windows one because we're a little bit more familiar here. So in Windows main CPP, this is all C++, so it should look pretty familiar to what we're doing right now, basically. But it looks like here, it looks like Ted actually did it sort of like the even more, we could say simpler or more obvious way. Like he's using the default entry point of a Windows GUI app, Windows GUI program called WinMain, right? So basically, whenever you like write something to like the Windows SDK in C or C++, and you compile it, this is the entry point function by default. And so basically everything he has is just procedural style in WinMain directly here. All of the window setup, all of the setting up the D3D and direct sound pipelines is all just in line right here. Yeah. So, yep. So he goes through and basically does all the stuff you would ever want to do on the with the OS layer here. There's some preprocessor stuff for Steam, for DRM, I call it. Setting up all of the like I/O buffers basically and event handlers for that. And then here we got to it. We got to the loop, right? I think I went too far. I think the beginning of the loop started a little bit ago. Here it is. Yeah, so this is the while quitting loop. And so everything is just procedural style in here. And this is all, again, I/O, then game state updating, game update, then game render. And then, there's like some cleanup stuff you have to do. Like you have to get like your time in between frames so that you can do like VSync or lock the frame rate to something. And then there's the sound out. And then some debug stuff. Okay. Yeah. So he has totally circumvented this by not doing what I did and overbuilding the abstraction before it was necessary. That's good to know. And it's actually very nice. I'm glad that like, hey, this is the working example of that working, right? And we want to see the other one. So metal. Oh, this is in metal view delegate. Oh, so on Mac, you have this concept of like delegates basically, and these are, you have like the event emitters, I think, are the main objects. So for us it would be like the NS window or the I don't know if it's like the MTK view or the metal view, right? But then you have the metal delegate. You have delegates that are the async event handlers to all this crap. And because basically, the goal of doing this, writing games this style basically is to take ownership of the rendering loop in the window as much as you can. You on Mac, you dump every single thing into the delegate. Oh my god. Oh my god. Oh shit. That would do it. Um that that would do it. And look, this is draw an MTK view is going to be like the function that basically is called by the window every frame or whatever whenever it's ready, and then it goes through and does all the game stuff here. That's where all of this is actually happening. And then there's a bunch of like cleaning up, resetting the all of like the render, command buffers, all this stuff at the end. It looks like there's maybe the actual actually go draw stuff on the screen somewhere. Set the shaders. Oh my god. Oh my god. That's it. That is kind of the model that we're looking for. I'm curious to see, this is the last thing I'm going to do because I'm running a little late now. Where is this called? This is literally just called in that Mac platform. So when we get to display link callback, this is that not quitting. So this must be looping, right? To actually get into here. So who knows what a display link is, ladies and gentlemen? Shall we see where that is getting called at? So that is getting set here, and this is pretty soon in the NS window init to actually grab a window and shove an app onto like the taskbar in Mac OS. Yeah, this is all the code that I've been playing around with for the last couple of days. Okay, well that's good to know. Probably should have done that first. Always good to really thoroughly read, because again, this is went in kind of some knowledge about how this architecture or this setup worked on Windows. And again, most of it translated very directly of we are doing pretty much all of the same things. But anytime you're working with someone else's code, you have to learn their stupid abstractions, their quirks of how their platform, their code works. And that is kind of like what was missing from our understanding of how Apple was doing things. And so now we know, okay, this is the thing where we got to dump basically everything into, and that is where we do our metal stuff. So that again, that is all great to know. That gives me a lot better direction, I think, as I try to understand what the abstraction and the split up should be for my code base, because it's not necessarily going to be exactly the same as whatever Ted came up with. That's what worked for him. We have a bunch of existing code, but again, this is the point in time where you have to be we can be as flexible as possible with changing stuff to get it to work and to get it to be nice to develop multiple platforms on. So we will do that. I will be back online tomorrow morning. We'll have some more fun stuff, sip some more tea, and thank you for joining me today live, TL Security. I hope that you had some fun watching the stream. I hope that was interesting or enjoyable. There's very little typing of code today. Some days are like that. Some days are a lot of yapping, but this is definitely an important one to think through. So have a fantastic rest of your day. I hope to see you again next time, and we will keep on programming.